Hello, everyone. My name is John Sofra with Kinetics Noise Control. I'm the Director of Sales for North America for our industrial in-plant manufacturing plant, our environmental outdoor noise control, and our airflow attenuation markets. And today I want to present to you a new product that has been in the works by Kinetics engineers for a period of time now, and they've developed the perfect product called a NOISEBLOCK QuickWall. We've seen opportunities in the field, a lot of them retrofit, where we needed a alternate solution than a rigidly attached rooftop barrier wall system. And that's what we've come up with here. Once again, it's called a NOISEBLOCK QuickWall rooftop ballast barrier wall system. So as we get started, um, we say here at the top of the screen is a premium noise control solution without a premium investment. And we'll cover what that means. It's still the same Kinetics noise block barrier wall system that people have come to know over the years and has been offered since 1958. However, this is a new system where the initial product cost might be the same or a little more, but the installed costs are greatly reduced. Hence, the total cost to the client and owner is reduced. So we'll cover that as we move forward. Just to get you in the mood here, here's a little video. There's no sound in this video, but it's a kind of lets you see what we're talking about. You'll see some systems around some rooftop equipment. Now that we're in the mood to talk about this product, to let you know before we get started as well, is there is a data sheet, a flyer front and back on this product. So everything we cover in this presentation is going to be covered or reflected on this data sheet. Whether it's the application, the features and benefits, dealing with the sizes, different configurations, seismic finishes, rooftop types, and acoustic performance. It's all here. So we'll cover it in the presentation, but also you can download this from our website. So these are some screenshots from the video, some renderings of a project that we have planned to do. And you'll see there's a number of three-sided noise block barrier wall systems around some rooftop equipment, air handlers, light duty equipment. And there's some windows in the back here in an office building. So they're worried about the noise projecting from these units to that office building. Now, we can do both three-sided systems or four-sided barrier wall systems. We're showing a three-sided here just so you can see what's going on inside, okay? We open up this wall here so you can see what's going on. So it is available in four-walled systems or three-walled systems. You'll see here the common components of a noise block barrier wall system. You have your base plate plus column welded assembly. You have your 4-inch thick noise block wall panels, usually perforated inner shell for sound absorption and solid outer shell for sound blocking. So you get that composite noise reduction offered by the absorption and sound blocking. The only thing different here is you're going to see something low at the bottom, these little boxes. And that's where we talk about the ballast of a system. So just looking at the quick wall ballast, well, what is a ballast? A ballast is basically a heavy material placed low on a subject matter to improve its stability. And that's what we're doing here. As we said, you have your noise block panels, your structural steel. This is an example of a three-sided system, of course. And then you have your ballasts down here, which are basically weights. We're going to determine how much forces are there, how we have to overcome those forces, how many weights we need, and what is really feasible to be taken up, because this is also going to be weight on the roof. But the key here is, going to the previous slide, is that if you look here, there's no anchor bolts. So this is not rigidly attached to the roof structure. And that's the key here and what's going to reduce the costs. When I talk about applications for this product, this QuickWall product, I put in the right corner here, retrofit and new construction. The majority of the benefits of this is, the initial benefit is in retrofit applications, where there is equipment up on a roof. All of a sudden there's no problem, it's new construction. A year later, maybe somebody moves in next door and now there's a noise issue at the property line and we have to quiet this down. So just keep that in your mind from a retrofit perspective. A lot of this presentation Some of the comments, features, and benefits are going to be retrospect or a function of being retrofit. Also, we can use it for new construction though. And once again, this is all for community noise compliance, rooftop systems, where, it could be a restaurant, commercial buildings, schools, worship centers, anywhere where there could be an outdoor noise issue, and also for rooftop equipment, air conditioners, condensers, fans, pumps, anything making noise. So why is there
Hey
a
John, we have a
benefit?
couple of questions.
Oh, I'm sorry. Great. Yeah,
Oh,
we didn't mention about questions at the end. So let's go ahead and answer them as we go. That's great.
okay. Yeah, so the first question is, can we do one side or two side wall systems?
Right now, we're doing a three-side and a four-sided wall system. We are looking at one and two-sided wall systems, and they should be able to be done. But right now, most of them have been three or four-sided. So I'd say the answer is yes, but we would want to look at the application. Now, why is not rigidly connecting this to the roof a benefit? Well, one reason is remember we were talking about retrofit. Maybe the equipment is already there, and we have a noise issue. We have an existing roof. We're going to eliminate the need for these roof penetrations using this system. So now we don't have to worry about any water leakages in the future. We don't have to worry about having to get under the roof, the existing roof, to access if we have to rigidly tie a column into the system. So those are all very important things and benefits of this. The other thing is it's not going to void a roof warranty. It's not going to interfere with the roof warranty. There's also shorter permitting processes when compared to systems rigidly attached to a roof structure. There's quicker installation. And then the other thing is although we want all contractors to be very busy all the time, this actually would reduce the need for multiple contractors. If you don't have to penetrate the roof, we don't need a roofing contractor. If you don't need to rigidly tie to the existing roof structure, we don't need a structural contractor for this. We might not need a mechanical contractor, or we may only need a mechanical contractor. So now we're eliminating all these coordination challenges as well. So those are some very upfront benefits to this system, which basically floats on the roof. It's not rigidly connected. QuickWall cost impacts. So what I mentioned on here is the initial cost is about the same for our standard noise block system. So our noise block system with structural steel base plate upward, you have our panels, you may have doors, you may have acoustic louvers. There's a lot of things that can also be installed in this as well. That system's it holds true in the same price. There's a little added cost due to the price of the ballast, because we're going to have to add these counterweights, if you want to call them, these ballasts to the system. So the initial cost might be slightly higher, but the installed costs are much lower than a rigidly connected system for a lot of the reasons, where we don't have to penetrate the roof, we don't need multiple contractors, we don't need to tie into the roof structure. So the total cost, when you combine the two, there's a large overall savings to the owner, and that's what's really important with this. Now, when we look at this, is this system applicable for all applications? The initial answer and the easy answer is no, not all applications would this be applicable to, but for many it is. And what we have to do when we design this is there's a lot of things that are considered. One is we want to design it to resist any tipping due to wind forces and uplift forces and the lateral movement. It's skidding across the roof, right? And so we want to look at how many ballasts are needed, how much weight is needed to counteract those forces as they're designed into the system and the resulting forces. The added weight also provides additional friction. So right here we see a ballast in this view. And in this ballast, there is basically our column and our base plate. We have our barrier wall, noise block panels, but then there's a little, I kind of have the top off here. There's a covering top that goes on here, but right now I opened it up so you can see inside. This is a ballast, and basically what we're doing is we're making a framed member here with counterweights in it, and then it all sits on a proprietary pad mount underneath. And what we do is we also have, since there's no rigid support at the base plate, we also have a pad underneath that base plate as well. And so that's to protect the roof as well, also keep these datum points, these heights of the ballast and the bottom of the base plates at the same elevation. But what we do is we counteract those forces. The pads are proprietary to give us a critical contact friction. And the other thing is that this is good for both wet and dry roof systems. So these are things we look at because once you contact that, those are tests we have run in-house so that we have that all taken care of.
Would Kinetics provide all the components of the system, including structural steel and engineering?
Yes, and that'll be in a deliverable slide that we have at the end, but correct. Kinetics will design everything, and we can look on this page here, would design everything from base plate upward, including the ballasts and the proprietary friction pads, whether this is powder coated or not, all the bolts, nuts, washers to hold the panels in place to the structural steel. So everything is connected together in one complete package, almost like an erector set. And that's the nice thing of this. There's no field welding, nothing like that. Yes. Anything else?
Would the weight
Oh.
of these ballasts introduce the need for modification to existing roof structure to handle the additional load?
Yes, actually, you're going to find a point of limiting return, if you want to say. In other words, you know, if you have, let's say, a huge wind force, let's say 200-mile-per-hour gusts of wind, and we say, well, we can counterbalance anything. Well, before you know it, you get too many ballasts, you get too much vertical weight, dead load, and now your existing roof can't take that load anyway. So that kind of goes back to what I had mentioned. It's not applicable for all systems, for all applications. But in some applications where it's reasonable, even if it's reasonable and say, hey, we have enough ballast, we can do this, there will be some building structures where you might have to add some more structure to the building itself, separate of our system, but to our building itself, just to hold the vertical weight of this. And we'll cover that in another slide as well. Those are great questions. So these systems can be three-sided or three-walled systems. That is two flanking walls, basically what's shown here, two flanking walls and a connecting wall. It can be a four-sided walled system, rectangular or square, doesn't matter. The maximum height that we're limiting it to right now is 10 foot tall. That's pretty tall. Okay, so you might not be, it may not work for all systems due to the equipment height itself, but for quite a few systems it'll work. So maximum 10 foot tall, maximum column spacing. So the spacing between any two columns is 8 feet. All right. Now, if you have a system that's longer, like this is a little system here, this might be 8 foot by 8 foot by 8 foot, okay, in footprint dimensions of length. If you have a much larger system, let's say it's 20-foot flanks or 24-foot flanks and 70-foot long section here, maybe four-sided or maybe various walls of 90-degree angles to each other, we can do that. All that's important to do is the multiple columns have to be spaced on 8 foot centers. All right. So it can be any kind of footprint. It can be much bigger than this, but the columns will be on 8 foot centers. And then minimum wall lengths. If you look at something like this, and this kind of makes sense, if you look at something like a three-sided system here, and you have two flanking walls, the adjoining wall can't be any shorter in length, not height, but length, than 4 feet. So the connecting wall has to be 4 feet or greater. And so those are some of the things that we look at. It's a nice governing guidance for people. And as this comes in, as you have an application, Kinetics independent reps, whether we're working with engineers, architects, owners, this will come back into the house here at Kinetics, and our structural engineers on staff will look at this to make sure it's applicable for your application and the site conditions. A lot of people say, well, what are the applicable roofs? Okay, so any type of flat roofs right now. Now we are looking at roofs when you're looking at a slope of maybe a quarter inch over a foot. Those would be considered, well, they're not a flat roof. There's a slight slope, but those we believe we can handle. We think in the future we would be able to look at this in some form of a more sloped roof. But right now, figure flat roofs. Roofing material, all kinds of single membranes, whether it's TPO, PVC, EPDM membranes, no problem. And I think the biggest question that we get is, what about a built-up roof system with a gravel top layer? No problem. We have that covered as well. So just to give you an idea on that. So this is kind of goes with the limitations. They're not necessarily limitations. I think this should be limitations and clarifications. If we look at the top line here, this was one of the questions that came in earlier in this presentation, is older roofs may require additional roof structure to support the loads of the QuickWall system itself. So like we were saying, well, what if the existing roof of the building is not strong enough just to hold this and even mechanical equipment? Well, those are things where you might have to add some additional structural steel under roof line. One example of this is pre-engineered metal buildings. They great buildings, but very often they design those to the minimum requirement because they're not really meant to have stuff up on the roof as often. But usually it's pretty accessible to get underneath and that roof and add additional structural support. When you look at the wall height and lengths, they're all a function of the geographic location. Are we looking at a coastal location or an inland location? We want to look at the altitude of that location above sea level, and also the building roof height will be important. All this is taken into account by Kinetics' structural engineering team. The ballast quantity, like how many ballasts do we need? It's a function of the applied wind loads and the roof surface static coefficient of friction. So what's really interesting, this shows you here, it doesn't have to be one tier of ballast. It could be a multiple tier or double tier or triple tier of ballasts. So for higher wind loads, we add additional ballasts. And then this goes back to that equation, right? We could make the whole wall ballast, but eventually it's going to get too heavy. So we got to be reasonable. And once again, this is applicable for a lot of applications, but not all applications. Ballast quantity, we talked about that. And then I wanted to mention this too. As Kinetics meets the needs of this developing application, it really is a need out there. People have come to us, and that's why we've developed it internally. Um, when we look at the governing local jurisdictions and the higher wind speeds, we're going to look at this and figure out where we can use it. So maybe, well, not maybe. Initially, our thought process and the way we're using it is that there are no rigid connections. Let's say this is a simple system, but let's say it's a much more complicated. The walls are longer and different shape footprint and things. Uh, we may combine, or the plan is to combine them with rigid connections. So maybe you have 20 base plates on a job, column and base plates. On those 20 column and base plates, maybe only 6 or 4 need to be rigidly connected to the building, but the other ones can float with these ballasts. So that might be, it's still fewer penetrations, it's still lower cost of install. So be thinking that way as well.
What are the ballasts made of, and what is the typical weight of each one?
So the ballasts are, we have different size ballasts, and the more important thing that we talk about when we talk about ballasts is it's all meant for outdoors. It's all a dense composite, and the most important thing is the weight of the ballast. So I think that is the most important, not so much how much these are individually, because they do vary. They can vary in shape and size, and that's what we can do to see what is the best. How can we keep the lowest profile with these ballasts versus having to go two tier? So that's the best thing is that it's a composite material. It comes in various sizes, and we can alter the size of the ballast itself. When we look at the seismic exemptions, if your application is specified design category A or seismic design category B with respect to equipment, or design category C with an importance factor of 1, this can be applicable. All right. And now when we look at this and we compare this, say, well, that is with respect to mechanical equipment. What about if you're looking at this from an architectural perspective? So there's consistency when we compare these. There is consistency with the above of any architectural non-standard components, which this would fall under. So there's a good correlation there. Now, when you look at the map here, a lot of people ask us, well, can I use it in my area? That's the first thing people want to know. And so what we wanted to do was put something here that kind of gives you an idea of where you could use it. All right, right off the bat. Now, if you look at the red areas, which are low seismic areas, I'm not going to say you can use it in all areas here, meaning that if you look coastally, we may need to, due to wind forces coastally, we may need to have that situation where you need a lot more ballast than the roof can support, or we may need a combination of ballasts and rigid support. But as you move inland, as you move inland to these red areas, and you can use this product. So some of these areas are areas that you know right off the bat you should be able to use this product. The other thing is, though, that you got to be careful with is when you look in areas such as that's red here, low seismic, but it's in a sandy area. So that's going to affect things. Even though it's up on a roof, it'll depend how things are classified. So if you have something more like quicksand, not quicksand, but softer soil and sandy conditions. So those are some of the things we looked at. You can also look at it in areas that aren't even classified, such as the white areas here and in Texas, but once again, and in Florida. But once again, you want to look at coastally, we might have to introduce a combination of rigid support and this ballast type. Okay, so what is provided? So this gets back into the question that came on early on in the presentation as well. So just like Kinetics noise block barrier wall systems that rigidly connected to buildings that people are used to, you get the structural support steel, the design and supply. So we do all the fabrication at our Kinetics facilities, and we do all the structural design here by Kinetics internal engineering, structural engineering staff. You need PE stamped structural calculations by a structural engineer when required per locally adopted IBC. So we also can do some structural calculations. We can also have a mechanical engineer stamp it if that's applicable for an area, but we do have structural engineers on staff to cover this. Piece marked installation drawings, all the panels, all the columns, all the ballasts, everything come piece marked with bills of material and on the assembly installation drawings. We also call those record drawings for file. Systems completely bolt together, no field welding. All the holes are pre-drilled in the factory. All the nuts, washers, and bolts are included to put the panels to column connections to structural connections. All the friction pads are in there and everything. And then we have our local representation with Kinetics, which is really nice. So we have people that can come out to the field. They can go over installation with you. They can come walk the site. All that is available. When you want to look at the performance of this system is the same as a standard noise block barrier wall system, the acoustical performance. So all of our products are independently tested and backed per applicable ASTM standards, C423 for sound absorption and ASTM E90 for transmission loss. We have, often you're going to see these with a 16 gauge solid and 22 gauge perforated inner shell, or 18 gauge solid with a 22 gauge perforated inner shell. So we have all these available, and we can do solid too. We like to use a perforated inner shell because it helps reduce the noise levels before they can even impinge on the solid surface. And if you look at our construction and finish, once again, the same thing. Panels and trim can be galvanized G90 or Galvanneal A60 if you're going to powder coat finish or wet paint finish the product. Structural steels hot dip galvanized. Acoustic media is all suitable for outdoor wet, dry, freeze thaw applications. Under proper compression, you don't get any sag. This is all the same as our noise block panels. And then we can do powder coat or wet paint or just a mill finish, an unpainted finish. We can also look at barrier wall panels made of aluminum, which I realize is not on here, and stainless steel is too. So that is not on here, but depending whether your application is industrial or commercial, these are all available. So what are the benefits again of the system? It's not rigidly connected to the roof, no water leakage, no roof warranty issues. That's a huge cost savings to the owner and the engineer. Often this is going to be a retrofit application, but can use for new construction as well. The other thing is too, is that is it applicable for all applications? No, but there's a lot of applications it is applicable for. So with that, I really don't have any more. I just am happy that you're hearing about this product. It was a big need we had from the field for the last number of years. We've come up with a product, as Kinetics does with all our new product development. But if you need the product, or you're looking and saying, boy, I think I could use that, please contact your local Kinetics engineer or your Kinetics representative. Have a good day.